All right, so today what we're going to do is we're going to look at 4E, addition and subtraction with fractions. Now, this is not a difficult skill, but it builds on things that we've done in the past, and you have to remember when to do it. Now, why doesn't adding and subtracting fractions behave like adding and subtracting whole numbers? Can anybody remember?
Because you have to make the denominator the same.
Right, but why is it they don't behave the same way?
Because they're not the same.
Because they're not really numbers.
And also because they're not all numbers.
They're not numbers. What are they?
They're fractions.
A number divided by another number.
There you are. There's what I'm looking for. They're division problems. You're trying to add one division problem to another division problem. And that's why they don't behave, right? So they have their own special set of rules. Well, just because they have their own special set of rules, that does not make them difficult, and it doesn't make them impossible to do, but I can tell you, most of the year 11s and 12s I see don't know how to add and subtract fractions.
Is that why you said that kid?
Shh, no. All right, now, it is a skill you need to learn, right? Anyone in here play a sport?
Yeah.
Okay. What sport?
Rugby.
Rugby. Okay, do you know the rules for rugby? Does that mean you know how to play cricket?
Yes, he does know how to play.
Well, that's not the point. I'm just saying, if you know the rules for rugby, does that mean you automatically know the rules for cricket? Okay? Or baseball? Or some other sport? No. So, gentlemen, so that means that different things have different rules. You're used to this. So why is it that students in mathematics think everything should follow the same rule? It's just not the way it works, right? So knock it off, okay? All right. So what we're going to do is we're going to look at this. Now, last time we were here when we were looking at comparing fractions, I told you to remember a phrase that had two operations in it. And we're going to use that phrase a lot. Does anybody remember what it is? Well, it's part of that. The D and the M.
One math.
Division and multiplication. Divide, then what? Multiply. Right? And remember the things you're dividing. You're taking the LCD divided by your original denominator. And I'm putting it in brackets because that means you need to do it when? First. And then you're going to multiply that times your original numerator. And that's going to give you your new numerator. Remember that? That's how we change the denominators. Now, you don't have to use this process, but this can be done so quickly and easily in your head, whereas multiplying the top and bottom by the same number, etc., it just takes longer. As well as the fact that, remember, I know where you're going in your math, and if you learn some tricks and techniques that make your life a little faster, things a little easier, then you can get there. But then you don't have to worry about the longer processes, okay? It just makes sense later. Now, again, if you have a process for finding the least common denominator and changing the numerator, I don't want you to change, right? You never have to do something my way as far as the math goes, right? If you already know something that works every time. But if you don't know something that works every time, then you're going to want to change, okay? So here's what I'm going to do. I'm going to write down the rules of the steps. Oops, sorry. To add or subtract fractions. The rule's the same. It doesn't matter if you're adding or subtracting. That's a good thing, right? So one rule for both operations. It just matters what happens at the end. To add or subtract fractions, first, you must have a common denominator. I can't add things together that are cut into different size pieces, right? But if they're all cut into the same size pieces, then it's easy to add them together. Okay? Yeah, so that's why we must have a common denominator. However, if you change the denominator, you must also change what? The end, the numerator. Exactly. Okay? So, if we don't have a common denominator, then we have to get one. And for that, we use the LCD if we're going to change it, right? Now, however, if you change the denominator, remember the example with the pie, if we cut it into a bunch more pieces, then it's not going to be the same number of pieces you started with, the same whole number of pieces. So you have to change the numerator to match, okay? So we're going to talk about how to do that, and we've done it already when we were using the comparing fractions part, right? So, first thing, but now we're adding and subtracting, we're not comparing fractions. If I'm going to add two fractions together, how many fractions am I going to get as an answer? One. That's the whole point, isn't it? To put them together. Yeah? The same with subtraction. If you subtract one fraction from another, the answer is one fraction. So when you're dealing with these, treat them as one fraction. Let me show you what I mean. First, write the LCD under one big fraction bar. So we're going to write the LCD under one big fraction bar. And don't worry about keep the notes half and half so that you can, we'll do some examples of this right next to it so you can see exactly what I'm talking about when I do it. Right now, just write them down. Then, use the divide, then multiply pattern to get the new numerators, plural. Because if you're adding or subtracting fractions, that means you're going to have more than one, right? So if you were adding or subtracting 3 fractions, you'd have to use the divide then multiply 3 times, right? If you're adding or subtracting 2 fractions, you'll use it twice, okay? You're going to put those new numerators on top of the LCD. Remember, your LCD is waiting for you with one big fraction bar over it. So what it's going to do is you're going to end up with more than one numerator over one thing, over the LCD. But your whole goal is to combine those things anyway, isn't it? So why not write them all together as either addition or subtraction? And again, I'll show you what it looks like, and it makes it so simple. Combine. Now, combine is the math word that means either add or subtract, because you can do either depending on the operation that you're given, right? So think of adding or subtracting as combining. Combine the numerators, but keep the LCD. Don't change it. There's nothing else in the bottom with it, so it just slides over and stays your common denominator. Okay? When you're adding and subtracting, it's the numerators that you're going to combine. And the last step, simplify if possible. And remember, simplify means reduce to lowest terms. In other words, divide away anything that will divide into the numerator and denominator. Because sometimes when you find the LCD, you'll have made them bigger, and that means that there'll be something that will divide into both of them, so you have to always remember to simplify at the end. Okay? All right, shh, guys. So here we go. Say we have 2 over 5 plus 3 over 10. I'm just going to rewrite it so that we have the paper. So there's our fractions. The single most important thing you could ever do is make sure you know what operation you're dealing with. Okay, hold on. I'll call on people in a minute. Hold on. So we always have to know what operation you're dealing with. Otherwise, you're not going to know what to do. Jeffrey.
Yes, sir.
What operation is indicated here?
Addition.
Addition. Okay. The next most important thing that you can do, is ask yourself what kind of numbers you're dealing with. Because do whole numbers behave like fractions? No. Do fractions behave like decimals? No way. Do whole numbers behave like integers? You don't even know what that is yet. Just say no. If you change the kind of numbers you're working with, then you're going to have to use the rules for those numbers. And so in this case, first of all, the operation is addition. What kind of numbers? These are fractions. So we know we need to use the rules for fractions. Now, some of you probably think that you're not very good at math. But usually it doesn't have anything to do with not being good at math. It has to do with the way you present and study math. In other words, you think you should be able to just look at a problem and know what to do. Right? But you've got to instead think of it a different way. You need to make sure you know what the problem or the operation is. You also need to make sure you know what kind of numbers you're dealing with, so you know what rules to use. If you know what rules to follow, then you can concentrate on following those rules, right? But if you don't stop and do this part, then you're always going to feel lost. And it's not a good place to be. Yeah? So think about how you can make your time and your study time more effective by asking yourself these questions as you go. Right? So, what operation? It's addition. What kind of numbers? These are fractions. Now, if you had numbers that weren't all fractions, it doesn't matter. One fraction means the fraction rules take over. All right? How can I make a whole number look like a fraction? Just sing out. Put it over a 1. So every number can be written as a fraction, right? So, but you can't turn the fraction into a whole number. Yeah? So you can turn the whole numbers into fractions to make them behave like fractions. Okay, good. So so now I know that I'm adding fractions. So Oscar, where are you? He's not here today? Okay, well then he can't answer the question. Shh. Nick, out of the way. Nick. All right, Nick. Shh. Gentlemen. So, in order to add or subtract fractions, what must I have? So the same denominator. Good job. Miles Sturgis. All right, Miles. My denominators right now are 5 and 10. Are 5 and 10 the same number? No. So that tells me that I have to find a least common denominator for 5 and 10. Okay? So think about your rules. Ryan, what is the number one rule for finding the least common denominator? If the smaller number, what? Divides evenly into the bigger number, then which one of them is the LCD? The bigger number, right? All right, guys, does 5 divide evenly into 10? Yes. Then 10 is my LCD. So I'm going to write it down as one big fraction. So that's what that looks like. You just put your LCD under one big fraction bar. And remember, fraction bars are always flat. Does anybody remember what the slanted one means? Or. It means the word or. Fraction bar is flat. Good. Because it's part of like a division symbol. Okay? All right. Will Riley, just so. Okay, Will? If I change the denominator, however, what else must I change? The numerators. Excellent. Good. Okay. Joshua. Sorry. All right, Joshua. And I'm going to use a pattern for changing the denominator. It's called divide
And multiply.
then multiply. Right? Divide then multiply. Okay? Divide then multiply. Now, and what I'm going to divide is I'm going to take the LCD divided by my original denominator, and then I'm going to multiply that times my original numerator. And that thing is my new numerator. Right? We've written that down, but this is the pattern. So here we go. Oliver Myers. Okay, here we are. What is my LCD in this case? 10. What was my first denominator?
5.
Shh. So Oliver, 10 divided by 5 makes a what? 2. What was my original numerator? 2. So 2 times 2 makes what? 4. And there you go. Now then I just brought down the plus symbol. Okay? Let's do another one. Okay? Just everybody can do it. We'll just all do it together. Come on, guys. Face forward. Listen. What is my LCD?
10.
What was my other denominator? 10 divided by 10 is 1. And 1 times 3 makes 3. In other words, that numerator didn't change because that denominator didn't change. Right? So if the denominator doesn't change, then neither will the numerator. Well, now it should be painfully obvious to everyone in this room what to do next. What do you think you're going to do next?
I think you subtract them, sir.
You multiply.
No, you divide them.